Um, so let's talk about some basic things. The basic things are, and how many pages I have? That's derivative of sine of x is equal to cosine of x. You're gonna be using this tomorrow, not today, but derivative of cosine of x is equal to what? Negative sine. Okay. Okay. So therefore, integration of, if you think about this, integration of cosine of x is equal to what? What's the integration of cosine of x? Sine of x plus c. Good. So sine of x plus c. And integration of sine of x is going to be what? Negative cosine of x. And this one, usually people mess up because they thought it's positive, because derivative of sine of x is equal to cosine of x. But it's actually integration of sine of x is actually negative cosine of x. Because if you think about it, you can always take a derivative of this, right? It's going to be negative times negative becomes positive. And that's a basic thing. So d to the dx of tangent of x is what? Secant square of x, right? So integration of secant square of x dx is equal to what? Tan of x plus c. So far, any questions? Now I'm gonna d to the dx of cosecant of x. So that's equal to negative cosecant of x cot of x. So integration of CSC of x cot of x is equal to what? What's it equal to? Negative cosecant of x, yeah. So you can think about it backwards, right? So how about d to the dx of secant of x? So it's going to be secant of x, tan of x. So therefore, integration of secant of x, tan of x, it's actually very easy, which is a secant of x plus c. Let me know if you have any questions. We have one more. What's the derivative of the last one? What's missing here? Derivative of what? Cotangent of x is equal to what? Yep. So therefore, integration of CSC square of x dx equal to negative cotangent of x plus c. And this is just a basic trig integral. And if you did this, you're good. Now, I would like to tell you, we do missing some trig integral here. Can you tell me which trig I'm missing? Integration of 4 different one. What are the 4 things that we're missing here? Can you tell me? Do you see any integration of any trig function by itself is missing?
Negative side?
Well, no. Tangent of x, good. Tangent of x is missing because we have secant, we have secant tan, but we don't have tangent. We also don't have cotangent as well. And we also don't have a c of x dx, and also CSC of x dx. Now, those things are missing is because we don't have a proper math tools in order for you to figure out that. So we're not gonna figure out until next year, because when we come back, that's what we're gonna do, something called logarithm. You want an integration by log, and you cannot do anything until then. Also, yesterday, when we says integration of x to the n dx is equal to x to the n plus 1 over n plus 1, this situation will not work in one specific number. Which number would it be? -1. Why? Who says -1?
No.
You're right. It's -1. So think about it. If you have, so n cannot equal to -1. The reason being is x to the -1, which is 1 over x, right, is equal to x to the -1 plus 1 over -1 plus 1 plus c. So that's going to be x0 over 0 plus c, and that's not defined. So if this is not defined, there's got to be other way to take integral. And in order for you to take integral, you need a logarithm integration. Yes? Oh, I'm so sorry. Where's my QuickTime? And so obviously, integration of like a -1 or integration of 1 over x doesn't work. Okay, it doesn't work. So this something I forgot to mention, so it don't work. So need a natural log integration. And we're gonna learn this. And this one also need a natural log as well. So that's why we have our own problem that we cannot do here. And this is probably the, later on we're gonna learn a lot of things. Like Calc 2, they're still learning different integration technique. There are so many different techniques. Derivative is a lot easier because, and the things that you guys gonna be dealing with this year is only like U substitution and the integrations, but there's no fancy one like what they're doing. But it's missing this 4 integral on trig. Any questions here? Okay. So let's talk about particular solutions. So sometimes I will get a f prime of x, and not just say this is equal to square root x, and that just says f of 4 is equal to 8. And here's my question. So this is called a differential equation, because differential equation means it's a function that already take a derivative. Okay, this is a differential equation. Usually you can use this differential equation to find original function. But what did this is called a initial condition. Okay, what is the initial condition? Initial condition is a statement that help you find the particular solutions. So this will help you find particular solutions. So instead of particular solution, so instead of finding a general solution, which is plus c, this is going to help you find particular solution. Also, understanding is very much the key. So how do I go from f prime to f of x? What did you say? Yes. What do you have to do in order to get original function from f prime of x? Integral, good. So let's integral this, but when you integral this, it's gonna give you f of x. Does that make sense? So then if you integral this, it's gonna give you a x to the 3 over 2, 2 over 3, because that's x to the 1/2. And if you're adding 1, so it's gonna be x to the 3 over 2, 2 over 3, plus c. Now that just means f of x is equal to this. And we say, okay, well, that's a general solution. And can we find out the original solutions, a particular solution? Well, what does 8 and 4 mean in terms of graphing? What does this mean? F of 4 equal to 8.
X is 4, y is 8.
Okay, in the graph, what does that mean? There is a what?
It's a point then?
Yeah, they are pointing. Yep. Exactly. It was just a point, right? But remember, this is infinite amount of general solution. Infinite amount. But that point is going to dictate what that function is. I'm going to say like this. So I'm going to show you how to do it algebraically. This is the output. So output. This is the input. So then I can plug in 4 is equal to 8. So 8 is equal to 2 over 3 times 4 to the 3 over 2 plus c. So 8 is equal to 2 over 3. This one's going to be square root 4 is 2. 2 times 3 is 8 plus c. So 8 minus 16 over 3 is equal to c. C equal to 8 over 3, roughly. What does this mean? This means if I have a function that 2 over 3 x to the 3 over 2 is going to look like this plus c. So if you realize that c has infinite amount of possibility, just between -1 to 1. But why that point matter? Because that point is going to dictate that what the graph's going to be. So where's that point? 4 comma 8, right? So 4 comma 8. And then parenthesis. So you see that point is going to be there. The only one that qualify is when this reach that point. So we can let it play. We says, oh, let's reach that one point. There's only one particular solution, which is a particular solution need that initial condition. When they exactly met each other, that's what the condition fulfills. So we know that this is equal to a over 3. So we're going to enter in a over 3. Hopefully come back out correctly. And yes, we did. It's correct because the math just double check with each other. Questions? Okay. Sometimes life's not so simple. Remember, we have how many times you can take a derivative? Usually, when you graph curve sketching, you had to do what? 2 derivative, right? You can actually get 2 integration. However, each c is gonna impact So you have to evaluate the first c before you go into the second c. What I'm trying to say is, if you have a h double prime of x is equal to x minus 4, like this, and not just say h prime of 2 is equal to 1, and not say h double prime of 2 is equal to 4. I mean, sorry, h of 2 is equal to 4. It's possible for me to find out h of x, which is original function. But what you have to do, you have to learn to think. Say, okay, if I take integration of h double prime of x, it should give me h prime of x. Does that make sense? But there is a c. But you need to use those two initial conditions. You need to use the first one to find out what that c is. Because if you don't find out, it's going to be c. And if you integrate that c, it's going to be cx. Then it's going to be c1x plus c. Then you have to find out two c's. It's too difficult. So find one c at a time. Okay, so this is the initial condition for the derivative. This is the initial condition for the original functions. You had to use this one first to find out the first c, and then integral that c. For example, if you c got 2, then you have to integrate it. And then in order to get the second c. Does that make sense? So let's try it. Okay, let's try it. Because h prime of x is going to be integration of x minus 4. And that's going to give you x squared over 2 minus 4x plus c. Does that make sense? Now, if I plug in 2, it should give me 1. So 1 is equal to 2 squared over 2 minus 8 plus c. So 1 equal to 2 minus 8 plus c. 1 equal to negative 6 plus c. c is equal to 7. Any questions here? Did you guys get the same thing, or yes or no?
Yeah.
Okay, so I'm going to integrate the new c, which is x squared over 2 minus 4x plus 7, because that becomes your new first derivative. You integrate this, it's going to be x3 over 6. Why? Because that's 3. 3 times 2 is 6. Minus 4x squared over 2 plus 7x plus c. This is going to be original functions. But this is a general solution. Again, I can figure out 4 is equal to f of 4. So it's going to be 2 to the third power is 8 over 6 minus 2 to the second power is 4. 4 times 4 is 16. 16 divided by 2 is 8. Plus 14 plus c. Let me know if you have any questions. Are you guys doing okay or no? So 4 is equal to 8 over 6, which is 4 over 3, minus plus, I think, plus 6 plus c. So be 4 minus 6 minus 4 over 3 equal to c, which is negative 2 minus 4 over 3, which is c is equal to negative 10 over 3. So you can write down the answer is x cubed over 6 minus 2x squared plus 7x minus 10 over 3. And this is my final answer. Any questions? So today, you're gonna what? Every time you do this, a puppy dies. Yes, some of you guys do this every time. It pissed me off. This guy is interesting though. I follow him since he's 2012. He write a blog and he say the things that he posts on his classroom, just like those common mistakes. And he teach in Saudi Arabia, which is nice to teach in Saudi Arabia because teacher there is probably double or 3 times the salary here. Here it's 50,000. Over there probably 100,000 or 120,000. But then you probably don't have a lot of freedom there. So you probably cannot drink a beer if you want to. Can you drink beer in Saudi Arabia?
No.
No. Yeah. Yeah. So you can't even wear a rainbow flag, right? Huh? Yeah. That's kind of sad. So here is the no, hold on. I'm gonna send you hold on a second, integration. iCloud Drive, desktop, integration. This is the first one. Okay, so some questions are a little bit harder than the other, but we're going to talk about a harder question. So what I want you to do with this homework, you see this answer choice? You see all those answer choice? Cover it up before you do them. Put your hand, put a paper on top of it, or put something on the screen. You don't see the question. Try to get the answer without the multiple choice. I think there's some of those things that people have this tendency when you reading something, you tended to want to see the answer is that one. Like, I really like the how C look, and you find your way to think that is the answer. I'm going to show you a proof why you should not follow your direct instinct and just choose that answer. Okay, so I'm going to show you. So do not check the answer, but this is the only one that I think that it's very interesting. So I am going to show you this questions. Okay, I'll give you 10 seconds to think about these questions. Okay, number 1. And don't shout it. Don't shout your answer. Write down the answer. What do you think? You got 3 more seconds. 2, 1, 0. Did everybody write down a number? A letter? How many of you guys pick E? 3? 4? Now, I want you to think about it again. You have every tendency to look at an answer and make your doubt becomes an answer. Here's what the experiment I'm doing. Half of the class didn't do well. You choose E, that's the wrong answer. It's what? It's C. The problem is you look at the answer, you want it to be that way, but you're not thinking. If you just cover your question up, you might think a little bit more. Why did they ask you integration to pi q dx? Pi q is a constant, and then it's gonna be pi qx. So for all the homework questions here, they are super easy. You can probably breeze by the first 10 questions. So total 18 questions. You can probably breeze by the first 10 questions without issue. But cover up your answer. And this is how you're supposed to train for SAT. In SAT, a good student train for SAT, this is how you train. You're gonna don't look at the answer choice and just do it and try to get an answer first before you look at answer choice. Because that's what good students do. They don't need answer choice to figure out. Most of you guys have that tendency rely on the answer and trying to give you the feedback loop, and it's a bad situation. I want to figure out my own answer without looking at answer choices. I don't want to have a bias that link you toward the other way, because answer choice want to push you to one direction, right? And then you choose that answer, and then you're like, oh shit, I picked the wrong answer. It was a simple mistake. But the problem is you look at all the answer choices. You should be able to do it without it. Now, if you up down to no choice, then look at your answer choice and figure out from there. Reverse engineer from there. Do you see what I'm trying to say? Okay. So today's homework, you're gonna breeze by first 10 questions, which is all the way to here. You're gonna breeze by first 10 questions here because they are super easy. Now, the question get to 11, 12, they get a little bit different now, okay? Now, we're going to go specifically go to question 18. We're going to help you to do this question on question 18. Now, this question is a little bit harder. Again, don't look at the choice. We're not going to cover the choice. So, question 18. And we're going to do this question. At a point xy on a curve, d2y dx2, do you know what that meant? Good. Is equal to 6x. Additionally, the line y equal to 6x plus 4 is tangent to the curve at x equal to -2. Which of the following is an equation of the curve that satisfies these conditions? What are they looking for? How are you going to get there? Why is today's information able to help you solve this problem? Now, go. You guys got, what, 12 minutes? 12 minutes to figure out one problem is pretty generous.
Here's my test and 2 proofs, I guess.
2 proof.
Yeah, I did 2 proofs.
Nice.
Where's David's?
Somewhere. Oh, right there. Yeah, Asim, you're very good. You're gotten so much better than last year.
Yeah, that's for sure.
Like last year, you score out of test 60, 70, 60, 70. But this year, you were like spot on. I mean, you still make mistakes, don't get me wrong, but it was way better than. That's why I say you should be on the math team. You should be on the math team. There's no.
I'll come Friday.
Yeah, there's no other people are more deserving than you actually. Because you make it a super fast expressions and what happened?
You got new flags?
Yeah, Duke.
Duke.
Well, Margot. A is -3. -3. It should be. It should be the other way around, right?
Where?
Yeah.
So this one you got -3 over x plus 2, right?
Yeah.
Plus a is 5 over x plus 1.
Right here, I just took out from the out of the integral.
So yeah, you had to reverse.
Oh, I did. Damn.
You're supposed to plug in. You had to switch.
Oh, okay. I got you.
Well, I think this one I cannot give you credit, but
That's fine.
the other one I can give you credit. So yeah, 96.
I really cannot explain it. Yeah, I did something, but I cannot explain what I did.
Did you guys get an answer? You don't think you did it right?
dy dx.
I did.
No?
Curve which has so 6x is the double, so this is the line, and at that line. That's what they
So see right now, it's in my hand.
Oh no, it's just bro. On the curve, I do this. Equals 6x.
Just when the thing,
No.
the thing.
It's double prime.
Think about it, think about it.
Oh, I'm trying to find that.
Do that.
Two, then you plug it in for the slope at that point.
Oh, that's
So you're gonna go. No, you said do the derivative. No. You do the derivative of the line, because then that's where it's.
No.
ahead.
Cairo, you're on the right track.
What?
Yes.
So then you would plug in 2 and then set it equal to derivative.
No, I could still use it.
-2, not 2.
Yeah, negative.
Equals negative.
So what?
So the slope at that point. So then
Right.
that's what the derivative of the slope. That's the and the line. The derivative is slope. So you do derivative, which is.
So we are doing those questions here. Question 18.
He is.
No, we have double prime. So you do intervals. Single
Oh.
prime. No, that's just normal.
The original function. Yeah.
Okay. And then we do first interval to get the derivative.
Dude, I can't listen to people explain that. I just like understand them, but like I just like I'm not hearing it.
So today practice doing the homework without answer choices. You'll find it that if you match budget, you gotta answer that's correct by your own without looking at answer choices. Vincent, did you get it?
Yeah, that's right. Yeah, I think it's fun.
You do have double prime. You have prime.
3x squared.
I think it's 0, but I don't know if that's right.
Negative
Original function should equal to 8.
you do that again, well, just what,
Equal to 8. Wait.
F of -2 should equal to 8.
Oh.
Do you know why it's 8?
into the original.
No. F of -2 is 8.
Original.
Think.
F of -2 is. What does that even
So you said the original equation should be equal to.
Minus 6.
If you plug in -2 should equal
Oh, yeah.
The line, right?
Wait.
Yeah, but that would equal. Anyways. No? No, put it in balance. No?
Wait.
He's looking at the line.
Oops, I plugged in
Also,
something.
Plug 2 into the line,
That's what I was thinking, right?
and then it's into that point. Is there any?
So this is the last question of your homework, but that's not the hardest one. So.
How is it to another, and they have to touch, from the at that point, it's the slope, and then also where it is, so then you use the line.
Carol's talking in a good sense.
Yeah.
Talking big. He's got an idea of what we talked about, the graphing idea. You guys see it in the graph. What happens?
See it, visualize.
I saw the graph. You see it. You see a point coming, break. I saw it.
I can do it. Where?
Yeah, you see the point.
So the point of the intersection.
It just gets bigger and bigger.
Yeah.
And you have,
What is the double prime on the left?
He's got a correct drawing. He's got a very nice drawing. That's the idea to think about.
doesn't really matter, you know.
Ah.
So, this one.
Hey, we have the work today.
Okay, yeah, that's the
Try your best. Think about this, guys.
At that point.
Do it, right? Let's see.
Plus C.
And then down, -2, right? Down.
Double prime of both are equal.
Negative total score is 8.
So then you use it's essentially derivatives equal to each other at the same point.
For
first little bit of the first sample usually. But the normal one is just used for the use the original line.
No, okay, wait, no, I was invited up.
Alright, you guys gotta go.
Whoa! You two know like. The last question's always spicy, but you need to.
A little spicy.
Yeah, the one that keeps you up. When it sends you to sleep knowing night. Yeah.
Last night, you gotta be clutch. And be clutch on my homework, please.
It's about.
You could have finished all your homework at lunchtime.
Sure. What did you do?